Hey everyone, welcome to Driven Math and Physics. So we continue with electricity problems, and these are becoming more interesting as we look at more. So let's look at a new one. It says the total fixed resistance of XYZ combination is 5 ohms. So the total of this combination, remember I showed you the circuit. So that's the total of those the total of the resistors in the circuit is 5 ohms. The power supply is 20 volts. It says calculate, number one, the value of the variable resistor required to limit the current to 2 amperes. So they're asking us to say on top of the 5 ohm that the fixed resistors are contributing, what value of a variable resistor should we put for the current to be 2 amperes? So a few things we know. We know that the voltage from the supply is 20 volts. We know that the current that we want it limited to is 2 amperes. That's the total current of the circuit. Now, the resistance total from these two things should be voltage supply over current total. That will be 20 volts over 2 amperes, giving us 10 ohms. So the total resistance of the circuit, when this is the case, is 10 ohms. But now fixed resistors are already contributing 5 ohms. That means the variable resistors, variable resistor should be equal to 10 ohms minus 5 ohms contributed by the fixed resistance resistor. That will be 5 ohms. That's what the variable resistor would need to contribute. That's what we'll need to set it to limit the current to 2 amperes. I hope that makes sense. And then from there, they want us to find the new power dissipated in resistor Z. Now, the first things first, this resistor Z will be very difficult for us to find the power dissipated through it. The reason is because we don't know the value of its resistance. Okay, so they've not given us this thing. They've just given us a total resistance of the fixed resistors. So we're going to just do total power of the circuit, just to make sure that this makes sense, okay? And so total power of the circuit, that means it will be power equals voltage times current. What's the total power? Total voltage, that's total voltage is 20 volts, multiplied by the current 2 amperes, giving us 40 watts, okay? So from there, we know we have to look at the next one. It says if 60% of the energy goes into heating water, find the useful energy delivered in 5 minutes. Okay, find the useful energy delivered in 5 minutes. So 60% goes into heating water. 60% is the useful energy. Okay, so let us look at this properly. Now, if you think about it, we'll need to find first of all the energy in the circuit. Now energy is equal to power times time. So the power of the circuit is 40 watts. The time we're talking about is what? 5 minutes. So that's 5 times 60 seconds. This gives us let's see, this gives us 40 multiplied by 5 times 60. That's 480 joules. Okay, so from here we know that 60% of this, so energy useful will be equal to 60% of 480 joules. That gives us, multiplied by 0.6, that's 288 joules that we have as useful energy. So I think that's about it. What do you think? What are you finding? What are you finding? Is there anything we're missing right here? Is there anything we're missing? In 5 minutes, the useful energy. Okay, the useful energy in 5 minutes. I'm thinking, is there something we're missing? So they're saying here that the energy goes into heating water 60%. 60% of the energy. So if the total energy is 480, okay, yeah, makes sense. If the total energy is 480, then we might as well conclude that, wait a sec, have I made a mistake somewhere? Let me confirm. 40 times 5 times 60. Oh yeah, there was a mistake. Sorry about that. Oh my God, this doesn't make sense at all. Okay, so let me remove a couple of things. I'll remove this and that, and then I'll also remove this part, because the answer here is actually 12,000. So that means it will be 60% of 12,000 joules. So that gives us 0.6. That's 7,200 joules. This now makes sense. Okay, so that's about it. That's how you do this, and that's how you find the answer. But now they're also asking to say, discuss one advantage and disadvantage of using a variable resistor to control heating. So the thing about a variable resistor is you always have to set it to make movements with it, and as you do that, you have some energy wasted through heat, because you have to screw it and unscrew it. Then the other thing is there's an advantage that is a simple way to control current and hence heating rate. So it's a very simple way of doing things. You can literally control it by simply setting the resistor manually or even sometimes digitally. So that's what you do, and this is what you're supposed to do in this problem. I hope this is consistent with what you have done. Thank you so much.